Find all zeros of p of x equals x to the fourth plus 2x cubed minus 2x squared minus 3x plus 2. Then use the zeros, the end behavior, and a few extra points to sketch its graph. So we're going to start looking for zeros using synthetic division, and we know that the rational zeros have to be a factor of 2 because the leading coefficient is 1. So the possible rational zeros are going to be 1, -1, 2, and -2. So there are 4 different ones that we need to try. I'm going to start with 1. So our coefficients are 1, 2, -2, -3, and 2. So let's do synthetic division. And we do end up with a remainder of 0, which tells us that 1 is a 0 of the polynomial, and that also tells us that x minus 1 is a factor, and when we factor that out, it leaves us with x cubed plus 3x squared plus x minus 2. Now again, we need to use synthetic division to look for another 0. It could still be another 1, maybe -1, maybe 2, -2. When you're doing this problem, you just have to guess and try and see what happens. But because I don't want these videos to be excruciatingly long, I'm going to tell you that -2 is the other 0. So let's verify that with synthetic division. Now we're going to use the coefficients that we had left over here or here. So let's see here. We've got 1, and then 1, and then -1, and 0. So we are good to go on -2. So we've still got the x minus 1. This gives us an x plus 2. And this leaves us with x squared plus x minus 1. We can try factoring this trinomial, but we're not going to get anything nice using unfoiling. So we're going to use the quadratic formula to find the zeros for that factor. So we've got x equals the opposite of b, which will be -1, plus or minus the square root of b squared, so 1 squared minus 4 times a times c. This is a 1. Give me a moment to use the eraser to make that a little bit more clear. Beautiful. All over 2 times a. So we're going to have -1 plus or minus the square root of, this is going to be 1 plus 4 in the end, all over 2. And so we've got -1 plus or minus the square root of 5 over 2. Now we want decimal approximations so we can figure out where those are going to go on the x-axis. So we're going to need one for 1 plus the square root of 5 over 2, and also 1 minus the square root of 5 over 2. And if we use a calculator to get approximations, we end up with approximately 0.6, and then approximately -1.6. So our zeros are going to be 1, -2, and then these two expressions which we can approximate like so. And so let's get an xy plane to sketch our graph. So we've got 1 as a 0, and we've got -2 as a 0. We also have about 0.6 and -1.6. Our y-intercept is 2, so we know that we're going to end up being above right there. And our end behavior is just like x to the fourth, so it's going to be going up in each direction. we need to figure out what's going on in these little intervals right here. So to do that, we need to pick an x value that's between 0.6 and 1, and also one that's between negative 1.6 and negative 2. So those values, I'm going to pick 0.8 and then negative 1.8. And then we can use synthetic division to figure out what we're going to have here. 1, 2, negative 2, negative 3, and 2. Now this is going to be a little bit of a pain because we've got these decimals. But right now is as good of a time as ever to show you how you can do synthetic division using a calculator all in one go. So we know that we need to bring the 1 down. At this point, we need to multiply by 0.8, and then we need to add 2 to the result, which is going to be 2.8. And then we need to multiply by 0.8 again, and then this time we're adding negative 2. And then whatever we get here, we need to multiply by 0.8, and then we need to add negative 3. So effectively, we can do this in one go in a calculator. So if you start with a calculator, and you start with the number 1, now multiply by 0.8, and then add 2. That gets us to 2.8. Then keep that in your calculator, multiply by 0.8, which is 2.24, 2.24, and then subtract 2. And then again, keep that in your calculator. Now we can multiply the result by 0.8. And from that, we can subtract 3. And then keep that in your calculator, multiply by 0.8. And then add 2. And this gives us negative 0.2464. Sorry, I didn't write that super nicely. Negative 0.2464. And so that's going to be right about here. It's going to be below the x-axis, just a tiny, tiny bit. And we can do the same thing here. So, bring down the 1. Multiply by negative 1.8. 2 plus negative 1.8 is 0.2. Then we need to multiply this by negative 1.8. That should give us negative 0.36. Then we subtract 2 from that, so negative 2.36. And we multiply that by negative 1.8. This gives us 4.248. We subtract 3 from that, giving us 1.248. We multiply by negative 1.8. That gives us negative 2.2464. And when we add 2 to that, we get negative 0.2464. So we end up getting the same thing that we got up there. And so again, this point is going to be just below the x-axis. And so our graph in the middle is going to be doing something like this. And we know it's going up in both directions for our end behavior. And so our graph should look something like this. This is p of x equals x to the 4th plus 2x cubed minus 2x squared minus 3x plus 2. And there we go.